Hello there. Electromagnetism. We all know what it is, but not many really know why it works and how. Look at this ferromagnetic material. I'm not sure if it's iron, might be. Why does it stick to this? And why do some other metals not? But when you pass electricity through them, voila, they do. So electricity and magnetism are really just two sides of the same coin. Electromagnetism, which is one of the four fundamental forces that make up just about everything you know. Just imagine, like charges repel each other and unlike charges are attracted to each other in electricity. On the other hand, in magnetism, like poles repel each other and unlike poles are attracted to each other. Sounds like we're developing a theory for this. But I've really only stated the obvious till now. How this works? It really just comes down to Einstein's special theory of relativity. So one of the many things that Einstein's special theory of relativity says is that length and time are never really absolute. They differ from things moving relative to each other. So the laws of physics are only same in an inertial reference frame, which means a reference frame which both the objects that we are concerned about are moving at a constant velocity. So basically at a constant speed in the same direction. So what are the effects of length and time never being absolute? One of them is length contraction, which means objects moving faster relative to other objects take up a lesser amount of space. I'm moving faster relative to these spectators and taking up a lesser amount of space. How exactly does length contraction make electromagnets work? To see this, let's have a look at this neutral wire. It is neutral because it has an equal number of protons and electrons. And the protons are really just swimming in a sea of electrons. For the sake of our purposes, we can also visualize them to be in rows. So let's say the electrons start moving. Basically the current is just flowing through the wire. Nothing's really happening. We put our negatively charged buddy, ion 1.0, right next to the wire and push him in the same direction with the same velocity as the electrons. He will not just merely move along the wire. He will actually be attracted to the wire as he moves. So why exactly does this happen? Let's go back to the first scenario and look at this from an ion 1.0 frame of reference. When we look at things from his perspective, the electrons are not moving at all, since they are actually moving in the same direction with the same relative velocity. And the protons are actually moving backwards. Since the protons are moving in his frame of reference, they occupy a lesser amount of space and get more dense. And the electrons in his frame of reference are not moving, so they occupy more space and get more loosely packed. So these two changes combined together actually give the whole wire a positive charge. And since an ion 1.0 is negatively charged, he is attracted to the wire. So wait a sec, let's go back to our frame of reference. That doesn't really make sense. So we say it is a magnetic field created by the moving electrons that actually attracts an ion 1.0. And in his frame of reference, it is actually the electric field created due to length contraction that actually attracts him to the wire. So really it just depends on how you see it, electric field or magnetic field. Remember what I told you about them being two sides of the same coin? Okay, so here is an example of electromagnetism, which is the railgun. Now, as you can see, there are two rails and a leveler, which proves the fact that this wooden board is level, as well as a power source. Then, first let's just drop it on the wood. Nothing happens. Watch what happens when I drop it on the drop zone. As you can see, it's accelerating. So just to prove that there's no fishy stuff going on there, let me just swap the magnets around, turn them around on both sides, and I just drop it from this side. So sorry, that's a bit slow, the batteries are draining.
So let's have a look at this in slow motion. As you can see, the green arrow pointing towards the left denotes the force, the red arrow pointing towards you denotes the current, and the blue arrows denote the magnetic field.
And now, whatever innovation comes in electromagnetism, you know how it works.